Let's try another one of these questions where I give you 3 points and we have to figure out if those 3 points are collinear or not, meaning if they all lie on the same line. Remember, the way to check that is to find all the pairwise distances between those 3 points, and there are 3 of them, and then seeing if the sum of any 2 of those distances equals the third one. If so, we know those 3 points are collinear. If not, we know they form a triangle. So suppose I give you 3 points, and let's suppose they are, in fact, the following. A will be minus 3 minus 5. B will be 3 minus 3. And C will be 0, 6. OK, well, are those points collinear or not? Let's take a look and see what they look like on the screen there. And, well, what do you think? I don't think so. But let's verify that for sure and see if that's really the case. So I've got to find 3 distances. I have to find the distance between A and B, and then between A and C, and then between B and C. So that all requires the distance formula. So this would be what? Well, this would be the square root, and now I have to take 3 minus minus 3. 3 minus minus 3 is actually 6 squared. Plus, and here I see minus 3 minus minus 5, that's plus 5. So minus 3 plus 5 is actually 2 squared. So on this side, I see the square root of 36 plus 4, which is 40. Which, by the way, if you work that out on a calculator, and I won't do it, I did it before, is 6.32 stuff. OK? All right. Now, what about the distance between A and C? Well, let's see. I'll take 0 and subtract negative 3. That's positive 3, and I've got to square it. And then here I take 6 and subtract off negative 5, so I add, and I get 11 squared. So what does that equal? Well, 11 is 121. 11 squared is 121. And then if I add 9 to it, that's 130. And so that's approximately, if you work that out, 11.40 something. Okay? And then the last distance is going to be the distance between B and C. That's the last pair. And so I take 0 minus 3, which is negative 3, and I square it. And then I add to it 6 minus minus 3. So that's going to be 6 plus 3, which is 9 squared. Notice, by the way, these negative signs will be fatal if you're not careful, right? It's not 6 minus 3, which would give me 6, but it's 6 minus this number. So it's 6 minus negative 3, which means 6 plus 3. So what is this? Well, this is 81, and 3 squared. I actually should put parentheses around this. I'm being a little sloppy here. Minus 3 squared is actually 9, and 9 plus 81 is 90. And that's equal to around 9.48 something. Are these things collinear? Well, is there any pair of distances that add up to the third one? Well, certainly these two don't add up to 9, and these two don't add up to 6. But notice that these two are actually pretty close, but a little bit too big, right? 9.48 and 6.32. Well, they add up to, well, 11.7 or 8 something, which isn't quite big enough. So it's close, but not exact. So in fact, these are not collinear. So not collinear. But this raises the question, since if they form a triangle, is the triangle they form a right triangle? Well, that's actually pretty easy to tell, because if they formed a right triangle, they would have to satisfy the Pythagorean theorem, which means that one of the length squared plus another length squared must equal the last length squared. Well, let's ask ourselves, if I square these numbers, is there any way to add them up to actually make them add up? Well, notice that if I square this, I get 40. Right? If I squared this, I get 130. If I squared this, I get 90. And notice that 90 plus 40 is 130. So in fact, what I see is the following. The square root of 40 squared plus the square root of 90 squared, in fact, equals the square root of 130 squared. So that means that this side squared plus that side squared equals the third side squared. So this, in fact, is a right triangle. This is a triangle that happens to be right. And I was able to see that because there was a combination of sides that actually satisfies the Pythagorean theorem. Easy way to see if a triangle is right or not. Just measure the lengths of the sides, see if they satisfy the Pythagorean theorem. Great. Well, now you know how to determine if 3 points are collinear or not. And if they're not collinear, you can even figure out if the triangle is a right triangle or not. Have fun.